Hi friends, welcome back to my YouTube channel. So in this session we are going to discuss regarding Kirchhoff's mesh law. So what is this Kirchhoff's mesh law? And this law is mostly used in any of the electrical networks. So this law, please carefully try to understand so that it will be very, and please watch the entire tutorial and don't miss out any of the topics. So because all the thing is equally important to understand. Okay, let us quickly start with the session. So in the previous session, I have discussed regarding Kirchhoff's current law or Kirchhoff's point law. What is this second law? Or we can this say this is the second law of this Kirchhoff's law of electrical networks. So Kirchhoff's mesh law is nothing but called, or it is also called as Kirchhoff's voltage law or KVL, you can say. So Kirchhoff's mesh law is also called as Kirchhoff's voltage law, and it is also based on the conservation of law of conservation of energy. That is, energy can neither be created nor be destroyed, but however, energy can be transformed from one form to the another form. So now we will quickly try to understand what is this KVL, what the KVL, Kirchhoff's voltage law, Kirchhoff's mesh law says. So now carefully understand the algebraic sum of products of currents and resistances in each of the conductor in any closed path in a network plus the algebraic sum of EMF in that path is equals to 0. So this is the Kirchhoff's voltage law. See, you can clearly understand with the help of this equation instead of, and you can even remember the law with the help of this equation, or you can say algebraic sum of product of currents and resistance is nothing but voltage drop, we can say. Okay, so this is the IR, this is a voltage drop or the IR drop, I can say. So algebraic sum of this drop versus algebraic sum of EMF is equals to 0. Simply we can try to remember. So sigma IR plus sigma EMF is equals to 0. Okay, so this is the main law of Kirchhoff's. Okay, so Kirchhoff's mesh law or Kirchhoff's voltage law. So the algebraic, once more, I will try to repeat it. The algebraic sum of product of currents and resistance, algebraic sum of current and resistance in each of the conductor in any closed path. And the thing condition is it should be a closed path. Okay, if you keep it open, then it's not valid. So in a network plus the EMF, algebraic sum of EMF in that path is equals to 0, and both whatever you are trying to sum it should be of the same path. If you take IR drop in one path and EMF, if you sum from other path, closed path, then that is not valid. Whatever IR drop you are considering of one path, the same IR EMF should be added. Okay, the sum of these two is equals to 0. So this is basically the IR drop plus EMF sums is equals to 0. This is a simple way to remember Kirchhoff's mesh law or Kirchhoff's voltage law. So now the question arises, how to calculate this? Now the law is sigma IR plus sigma EMF is equals to 0. Okay, so how to calculate each one of this? First step is how to calculate this IR drop. Okay, or how to calculate this EMF. So first we will deal with how to calculate the EMF or how to sum up the EMF. Okay, so sign of battery or EMF. Okay, so see, one thing is, now consider this component. Okay, and also this component. So first you try to consider this component. Current I is flowing through this. Okay, so current I is flowing and this is a battery. Okay, negatively charged, negative and positive are connected like this, and it is represented as capital E. Here I would say there is a rise in voltage because the current is flowing from towards negative, positive to, I mean this is flowing towards negative. So whenever in the previous session I told you, if it is flowing from positive to negative side of the battery, then we can consider say that there is a rise, or the current flowing is in same direction of the applied voltage, then we can say that it is rise in power. Okay, in last session related to powers. So since this is moving, current is moving from positive to towards negative of the battery, then we can definitely say there is a rise in voltage. And similarly, if you consider the second component, the current is moving towards positive of the battery, which is the reverse of this. Okay, and it is represented as negative of the negative sign. With respect to negative sign, this is called as a drop in voltage. Okay, so in this way we have to understand. So if you have any doubt related to the direction of the flow of current and everything, please watch my previous video. It is very clear once you watch this. Okay, so next question is how this voltage drop can be calculated. This is very important. Now we got the EMF sum. See, there is rise in voltage, means how to calculate this? From this to here it is moving, means negative to positive it is. So it is rise in voltage. From positive to negative it is going, like in this way you have to remember. If battery, or I can simply say, if the direction of current is opposite to the direction of the applied voltage, then we can say there is a drop in voltage. If the direction of the current is in the direction of the applied voltage or battery, we can say that there is a rise in voltage. In simple words I can say this. Okay, so what is this sign of IR drop? Okay, so IR drop, this part is over. Now this part we have to deal it now. So sign of IR drop is very important. So see, consider this particular resistor component in which current I is flowing, and here it is positive and negative sign of the voltage. Okay, so now since current is moving towards positive sign, okay, since current is moving towards positive sign, actually it has to move from positive to negative, but current is moving towards positive. Consider this scenario, then what will happen? Drop in voltage. Okay, that is plus IR. And now I is moving, current I is flowing in the resistor component, and voltage which I am taking it as minus and plus. So there is a rise in voltage. There is definitely a rise in voltage which we have to consider with respect to this. And since the current is moving from positive to negative here, we have to take it negative sign. Okay, so in this case, at least in voltage, so we have to take, remember, in one way, the current is flowing towards positive of the battery, then the sign is positive. The current is flowing towards the negative sign, then it is negative. Correct? As I already mentioned, if current is flowing towards positive, drop in voltage. If currently flowing towards negative, rise in voltage. In the same way, if it is moving towards positive of the voltage, then we can say that there is drop in voltage, and we can say that it is IR. If it is moving towards the negative part of the voltage, I is moving, then we can say that it is, if it is reversely connected, actually the connection should be plus and minus. If it is connected in reverse manner, then that is minus IR. Okay, so there is a rise in voltage, because a rise in voltage, why I am still telling is, from negative to positive you are going, you are traversing from negative to positive, so rise in voltage, but it is in opposite to the direction, so we have to take it minus. If it is moving from positive to negative, drop in voltage, and since it is going from positive to negative, there is drop in voltage, but the sign will be positive. Okay, so and there is drop in voltage. So in this way you have to try to remember, okay, some of the conventions related to Kirchhoff's laws. So this law is very important, because unknown current, with the help of this law, as in the previous session I have discussed. So in the previous session I have solved one problem also. In the same way I try to calculate the unknown current. Okay, so in the same way here, if you want to calculate unknown voltage in the network circuitry, then you can easily calculate the unknown voltage. You can just traverse in one of the loop, and you can sum the IR products. Okay, and you can sum the EMF, and you equate it to 0, and if there is any unknown EMF, then you can easily calculate. If there is any IR which is unknown, then you have to have two loops, then two or more loops, then you can apply KVL to two loops, and using some mathematical approach, okay, of solving the equations, you will get some 2 to 3 equations with, if three equations, three unknowns, In this way, you have to solve the using the mathematical concepts. So please do subscribe to my YouTube channel and press the bell icon to get the latest updates or notifications. And very importantly is, please comment in the YouTube comment section so that which topic has to be covered or is there any issue. So please try to comment in the YouTube comment section. I will definitely try to cover the topic, not only with respect to KCL or KVL, anything okay related to electrical, electronics, physics in general. Please do it. I'll definitely conduct a session on this. So have a nice day. Thank you. Bye.